Well, today, and it's Mothering Sunday, so I've got quite a few church services, and I've got half an hour before I've got to set off for my morning one. We've got this frustrated order. So this is where a set's come in for repair, and then they've changed their mind. So it's been abandoned. So we'll be sorting this out and selling it on eBay. And this is a Fidelity 1000, which is the posh version. What, a posh version, you ask? Yes, it's the one with the extension speaker socket. So some of them don't have the extension speaker socket, which leaves them a bit, what's the word? You can't really fit it in a vehicle, can you, with 1.5 watts of audio coming out, unless you've got an extension speaker. So that is good. It's in lovely condition, and it comes with a replaced power lead, a standard coffin replacement mic of the type we would use, terminated in a Midland type of 4-pin plug, not the general one, but the Midland type, the kind that came with the Precision series. We have seen these on the surplus market, and someone's also put banana plugs on it, so that's great. We'll plug that straight into the power supply. So you can forget all your Rotel 240s, because as far as customers go, these are the most asked for sets to be serviced. And we know they're bleed-over boxes if you live in a city, but if you don't, they work well. They're a 3.5 watt radio. Sometimes they do more than that, and sometimes they do 1.7 watts. But I have once seen a 4 watt one, so, but it makes no difference, as we've demonstrated time and time again, for people who are power mad. It makes no difference between 3.5 and 4 watts. You don't get 7/8 of the range. It doesn't work like that. You probably get an extra footy on the 4 watt one. But we don't know what this one's doing, and we don't know what it's going to be doing when it's been through workshops here. So we're going to power it up, and it's put 13.8 volts straight on it. It's lit up, and it's on a sensible channel. It's picking up our signal generator, which is not even set yet, but it will be somewhere near. So test instruments have only been on 10 minutes, so we're going to take some of the readings with a pinch of salt, because I need to spend half an hour. But I thought I'd get this on with, because I've got so little time today, and I want it out today. Okay, so we're going to start off. Let's put picture in picture on so you can see what's happening. And we have got 2.5 watts on channel 20. On channel 40, we've got 2.3 watts. And on channel 1, let's make a guess, 2.6? No, 2.5. So go back to channel 20, and we'll see what the current consumption is. 705 milliamps. Yeah, that's a bit low, isn't it? And on low power, it's doing 210 milliwatts. So the specification says it's supposed to be 10 dB attenuation of 4 watts. So that's a bit more than 10 dB. In other words, dividing by 10 in this case of 2.5, which brings us to 2.1. And it's non-adjustable on these radios, but we'll see what it does when the set's been tuned. We'll look at deviation, but I don't know on this test set whether the deviation meter's behaving today or not, so we'll be testing it on the one behind when we've got the set opened up. So just for the giggles, wow, it says it's 2.7, and I'll just put that there at the side. We won't be doing the VCO. If it works on all 40 channels, which it does, there's no point in doing the VCO. It's very stable on these sets. Frequency, again, we'll take that with a pinch of salt, but let's have a look at what the frequency says. 2779085, so it's not off frequency, but it needs pulling up. 27 79085. Just make sure you saw that. So without opening setup, we're going to set the receive, in other words the signal generator, to that same off frequency slightly, so that when I tell you what the performance is, I'm telling you as off frequency as the radio is, so that it's accurate. Did you get that? Put another way, if I put the signal generator spot on frequency, it would test signals and all that would show the radio not to be as good as it is. So 2779085086 is where we have the signal generator, and we can now hear that. The squelch on these is AM, and people like the gentleness, and I need to plug. I was doing a Viper 88. We've spent 2 days of 2 sessions a day on it, and one of the problems with the PT40 is that there's various versions of the board. So we've got the full manual for the low TX40, that's fine. I like those. But some of the others, the circuit diagram and the part designations differ. So it's very difficult to find your way around. So it's not an ordinary fault on this one we're working on. No transmitted audio. I've had to put it to one side, or we're just not going to get anything done, and there's customers wanting sets. So that goes on one side, and that was a gift from our viewer Chris, and which was very kind of him, but we can't launch the video on that because I haven't finished it. So I've got this connected up to the cyanide meter. These are very sensitive sets usually, too sensitive for their own good. So for 12 dB, got 0.34 microvolts. Now they're difficult to set up on receive, so these figures may get worse to get a better result. Do you understand that as well? Because if the detector's out, it will be garbled but might have better sensitivity. And for 20, 0.68. I mean, they're incredible figures. Squelch. So we've got full squelch on the radio at the moment. Let's just go on to the attenuator and just dial in when it opens. I want it to be 100 microvolts. It's not. It's a wishy-washy 10 microvolts. Threshold. .85. Okay, back to transmit. Look what the meter says. It's banging across. So although we like to set meters for 4, whether they're doing whatever watts, this one's banging across. So instead of writing banging across, it's FSD for full scale deflection. And on receive, 100 microvolts is supposed to be the standard for S9, and it's banging across. So let's see what S9 is. It is 8.5 microvolts for S9, which is ridiculous. So the meter lamp's working, the switches are working, the potentiometers are working, the socket's working. It doesn't have PA, and the mic it's come with is working, and the speaker's working. Well, that's ticked the whole pile off, hasn't it? So hopefully we've got time to do the transmitter. I've put my soldering iron on because we're going to need to take off the speaker. I'll add some paint to the bezel. Chances are I'll be taking the front off, seeing as we're selling it, and the knobs, and putting it through our dishwasher. I'm taking the wrong lid off, aren't I? What a fool. I'll be playing all the wrong hymns at church if I'm like that today. Very clean inside. Original speaker, because it says great on it. And we've got the screen can in place, which if you find this missing, you know, you start to think, what's happened to this radio? So things that can cause low power would be this resistor there. This is a 65. If it's been on a bad SPR, that can burn up, and this isn't doing low power because it's doing 2.5 watts. By low power I'd mean less than 1.7. So this has got the extra circuit here with a coil we don't adjust. That is the second harmonic trap done with the spectrum analyzer. So there's no need for me to touch that. One of the reasons we do scratchy corner is we just know how a radio should perform at scratchy corner, and if it doesn't, then it would come back to the bench. We'd go on to the spectrum analyzer. I don't put every set on the spectrum analyzer because it takes time, therefore it costs. So the power lead's been neatly replaced, and the protection diode is in place, and we can't see any dodgy capacitors. So it looks a low hour set. People, they'd say pre-loved, wouldn't they, with the second-hand market? But this could be pre-hated, because you either love these or you hate them, and I love them. There's quite a lot of. I've had a customer drive 270 miles to bring one of these for service, and I've had him drive 270 miles back. So let's look at the transmitter. So the tune-up starts there, up those, there, and finally with that one. That doesn't have a core. So at the moment we've got 2.5 watts. It's going to drop as the temperature of the radio transmitter heats up. The idea is getting a centralised peak, not just a peak. It's a matter of going beyond that peak and then determining where the peak really is. Otherwise you can end up with it lopsided on the channels, you know, with like 2.5 watts on channel 20 and 1 watt on channel 1 and 4 watts on channel 40, which is not desirable. So every single one of these has needed to be centralised, apart from that one. See, as soon as I say something, it proves me wrong. So 2.7. 2.8. doing 3 watts. Just check the placement of that coil. Nothing's been touched in this, so there's no reason to suspect no. So if I put this now onto a hobby meter, and I ought to do that, seems to be selling it, it'll be doing quite a lot more than 4 watts. This is a commercial test set, and it doesn't read interference out of its band. Its band is 24 to 33 megs, so if there was interference in that band, of course it would show it. But what it does, it puts up if there's a lot of harmonics, it puts up an emergency light, and so that then alerts us to put a radio on the spectrum analyzer. So what this means is that the power this is doing is actually all on 27 megs, and it's not elsewhere. We've all seen the sets that some Wally's messed with, and they're doing 7 watts, and then when we put them on the test set, they're actually doing 2 watts because the other watts are elsewhere. Right, so let's look at the other channels. See if I've got it pretty well balanced. So remember, we've got bang on 3 watts on channel 20, we've got 2.8 watts on channel 40, and we've got 2.8 watts on channel 1. So it is well balanced. And I'm going to take these, I'm actually going to inflate these figures because the set's now hot. In fact, I'll tell you what, we're not even going to write these down. When I come back from church, we're going to do the power reading again with the set from cold, which is a more genuine thing. Two-way radios in general are 5% transmit. What's the word? Duty cycle. Duty cycle's the word. So we'll just see what low power's doing. It's doing 0.2. So again, that will be 210 milliwatts, just as it was. Transmit current is now 730 milliamps. Right, I think it's time to put this on frequency. No, we'll tune the receiver first. I'll come back after church and do that. So the 2 detectors are here, and you've got shaping and actual detector. It's done an unconventional way, not using a clever FM chip like most FM CB radios. The LCL communicator is another one with a strange receive setup. There are others. By and large, the Cybernets and the Unidens and those type of makes, and the Maxons, therefore the Midlands and so on, they've got the MC3357 Motorola chip, which is an FM receiver in a chip, and uses very few external components. You have a detector on the end of that, and that's about it. But this, it's done with more transistors. It's Taiwanese. It's a cheaper product. Right, so at the moment we've got this very good sensitivity. Let's just see whether we can change that, hopefully in the right direction. It is that one. So I've got the sine nanometers were about 4 dB, and We've got the Noxyman cyanide meter kit, which we're putting together, doing a video on as well. Mr. Chippy's putting it together. So he's just been putting that in a metal box. So we'll be playing with setting that up, and we'll launch a video on that, and no doubt it works fine. You know what? We've just gained a fraction. This is the front end. The next one, absolutely spot on. Now we have the difficult one. So it's a 100 microvolt signal. We're going to look at the oscilloscope, detector and shaping. Yeah, we've got a gain there, which may be a loss in sensitivity. So there's, in the service manual, it's a sweep generator method. I've shown that a couple of times, but using the cyanide meter is quicker and just as accurate as far as I'm concerned. I just don't think that cyanide meters were very prevalent in workshops in 1981. We certainly didn't have one then. Go back to the cyanide meter for this one. No, I think that's where we are. Let's have a look now at the new figures. Are they better? Are they worse? So for 12 dB, but I'll tell you what, let's put the cyanide meter on so you can see that I'm telling you the truth. We now have 0.36. So that was the warning if the detector was out. For 10 dB, we have 0.31. And for 20 dB, 0.71. So with the detector being slightly out, you've got increased sensitivity but less legibility. The voices would be a bit garbled. So that's what that's done. Now we need to sort this squelch out. So I've got the squelch at full. Let's just see whether, well, which one is it? It's either this one or that one. Well, that's S meter. So I've put 100 microvolts now on the attenuator. I want it to open. There. There we are. That's now 100 microvolts. So let's look at the sensitivity at the other end. Set threshold on the radio. Signal generator back on. We've got 0.65 microvolts. So that's balanced up beautifully. So whilst we're at it, We'll just make sure the S meter's now set right. Want 100 microvolts for S9, which actually its minimum position. Can't quite achieve that. It's actually 110 microvolts. I'll set the transmitter for 4, even though the radio is doing 3, probably 3.1. Wherever the preset is, it's a bit tarnished, so I can't see it. So remember, it was full scale deflection. We want it to read. Actually, we want it in the centre of the red zone, to be honest. That's what the manual says. So we'll do the frequency when I come back from church, and we'll do the power reading. Wow. Do you know what? That's virtually spot on. I'd like it a little bit more. It's peaking at 2.3. Wow. These have brilliant audio, don't they? Right, we'll go back to the normal test set and we'll see what that Marconi normal test set says. On the deviation. Wallow. Oh, wrong mode. Wallow. It says about 2.9, so it's not playing ball today. So it was far from 2. It was about 2.2, which is okay, but you can have a little bit more. So again, there comes the point when it becomes. It's not like a mic gain thing. Once you hit the 2.5, if you go any higher, any radio with decent filtering is going to start chopping the edges off. So it actually decreases your talk power as you go up, unless you're being received by a set with an open barn door of a receiver like a Fidelity 1000. Don't get me wrong, I may be being a swine over it. I still love these to bits. Right, so frequency, let's have a look now, after everything's warmed up, 4 hours later, what we have for frequency. It's 27,79106, so if things are warmed up, it's come up a bit. I'll just pop the power off because of me opening the setup, the VCO cover should I say, and I don't want to short anything out. I don't think this has ever been off. It's a complicated VCO arrangement. We've covered it many times, but this doesn't need touching other than the frequency. So switch it back on and let's just pull that up. It's a nice quality trimmer capacitor. So we've got it toggling 27,79126. So it's just got that just slightly above so that it's got space to drop. Just put the lid back on that. it is good practice to make sure this is soldered. You can end up with microphony, and that's where you touch something and it gets transmitted, it rattles the electronics, so to speak. I'm going to put this on a spectrum analyzer. Something we wouldn't normally do unless there was a good reason for it. Just in case that filter's been messed with and it's in the wrong position. Right, so go over to the spectrum analyzer. Not that one. That one. The camera's moved a bit. That certainly looks nice and clean. That's just to stop microphony, not for any other reason. Pop the signal generator, the spectrum analyzer off. Just like that. Good, right, I think we are done. Let's put the lid on it and ascertain which one is positive, which one is negative. Could it be the grey one? No. Could it be the brown one? Brown one is negative. I think I've still got the plastic on that now. That's why it's the colour it is. Yep. Look at that. Protective plastic, eh? Right, I'll go and get a hobby meter and let's see what the power meter of the hobby variety says instead of the commercial one. Okay, so back on to, I don't know where the Zetagi one is, but there is a digital one and it says it's 4.1 watts. And on low power, it says it's 360 milliwatts. Now I've got this in tandem with our Marconi test set. In fact, I haven't turned that off. What I've done is plugged into the test set, so we're using the test set's dummy load. So on the 3-watt scale, 400 milliwatts is just there, and according to us, it's 220 milliwatts. So back to the full power, which is there, and key it up, and this meter says 4.1. and our meter says 3.1. So there you are. So I'm quite happy to put 3.1 in our box there. Three watts there. And 3 watts there. And it's 4 watts, isn't it, on there? And on channel 40, it's 3.9 watts. See where I'm coming from? We've got an outrageous meter on the shelf somewhere. It's a Bremy one. I can't spot it. Let's see what another quality meter says. These audio line ones are what's called a trough line meter. So that isn't really, this is a 1.6 to 60 megs ham radio thing. It's not a CB type meter. But this is a CB type meter, but these do go again up to VHF high band, so you can use these as a ham radio meter. So let's have a look what this says. So if that was 10, you know, what was it calibrated as? We don't know what it's calibrated as. 10, 8, 6, 4. So it's 4 watts, isn't it? So that's quite truthful. But our Marconi test set isn't showing you the interference, it's showing you what's on 27 megs. And that's what I want to see. But it's not how the figures are quoted. So what else have we got? Oh, what's this one? Is this the one we use for the field strength test for walkie-talkies? So, power 4 watts. And actually it's showing just over 3.5. So that's a fair enough figure. Right, let's put this on the aerial. Go onto its own speaker as well. One Nano Roger. No Roger. No Rogers. Right, we'll do an on-the-air test to that, and that's going on eBay.